Hello everyone, I'm Moumita. Welcome you all to this video lecture. Today I would like to talk to you about two most important and fundamental statistical tests called T and Z test. I know there are several questions in your mind related to these two tests. These two tests are same or different, and most importantly, what are those? No worry, in this lecture I'll be explaining all those things, and hopefully by the end of this video everything will be clear to you all. Okay, let's start the video. All right. Okay, first of all we should know small sample test and large sample test. These two tests are very common, and whenever I'm saying small sample test, that means we are indicating T test, and large sample test means Z test. Okay, that you need to keep in your mind. Okay, so before that we should know what is small sample and what is large sample. Suppose we are dealing with a sample but we don't know whether it is small or large. Okay, how do you know that our sample is small or large? Okay, for that reason we need to know what is small sample and large sample. Okay, basically we call a sample small if the sample size is less than 30. If your sample size is greater than 30, then you have large sample. If your sample size is less than 30, that means you are dealing with small sample. Okay, it is as simple as that. That means if you are dealing your sample size is less than 30, you are bound to use t test, and if your sample size is greater than 30, in that case you have to use z test for testing any hypothesis related to population. Okay, now when to use t and z test, that means what are basic assumptions, so that what are basic assumptions of these two tests means if your populations are not following these three assumptions, we cannot go for T or Z test. Okay, what are those? First is population. The population you are working with, you are dealing with, should be distributed normally. Second is the sample you have drawn, it should be drawn independently and randomly. Okay, third and last is you should know the population mean. If you don't have your population is not following these three assumptions, we cannot go for T or Z test. Okay, now applications or use of T test. Why should we use those tests, when to use, and for what, for testing what? So basically these are some hypotheses, and before that we should know t test is also known as students t test, okay, which is given by this well-known scientist W.S. Gossett. Okay, and first application of t test is to test for a specified population mean. Suppose one wants to know that a particular population mean is 13 or not, like this. But here the most important point is, in case of t-test we don't know the standard deviation of population. If you don't know what is the standard deviation of population and you are dealing with a small sample and you have to test a specific population mean, in that case to test that particular null hypothesis, t-test is best. Okay, next is to test equality of two means. Okay, here we have two categories for independent sample and dependent sample. If you are dealing with two independent sample and you wants to know, you wants to calculate, you wants to test quality of two mean, in that case you are dealing with small independent t-test. And if you are dealing with the same population but different sample, then you have to use peer t-test. Sometimes it also may be, sometimes people also may call it as before after test. Okay, that means here in peer t-test we are using different sample from the same population before and after applying some treatment. Okay. And next is to test significance of observed correlation coefficient. That means we can use t-test to know whether our correlation coefficient is significant or not. Last but not the least is to test the significance of observed regression coefficient. That means using t-test we can test whether the regression coefficient is significant or not. Okay, that's all about t-test. Next is our z-test, which is also known as SND or standard normal deviation test, which is given by R.A. Fisher. So R.A. Fisher. Okay, here also we have several uses of z-test. First is to test a specified population mean, but here most importantly we know what is the standard deviation of population. Here we also can use z-test for equality of two population mean, but again here we know standard deviation of the population. Third is to test for a specified proportion. For example, someone wants to know whether for a city the proportion of smoker is 50% or not. Such type of hypothesis can be tested using z-test. Last, test for equality of two proportion. For example, someone wants to know for two different cities the proportion of smokers are equal or not. So these are the important, we can say, important applications or uses of t-test and z-test. So these we have to keep in our mind. Okay, and let's move to the next slide. This is the very important slide. Here we'll be discussing about procedure of testing. Here I have these two tests. Okay, so steps are similar for T and Z test. The first test, what is our first test? First test is to formulate the null and alternative hypothesis. Remember, this is the basic step. First of all, before going to start any test, we need to know what is our null hypothesis, what is our alternative hypothesis. Okay, here I have taken an example. You might have some other null hypothesis that depends upon your application or uses. Okay, that we have discussed in the previous class. Next is level of significance. Then you have to decide whether you have to select whether your level of significance is 5% or 1%. Okay, next is calculation of test statistics. Okay, but here if you can notice that in T and Z test the only difference between these two statistics is S and sigma. Why? Because in Z test we know what is the population standard deviation, which is denoted by sigma, but in T test we don't know what is the population standard deviation. Instead we are using S. Okay, I'll be showing how to calculate S in the upcoming slides. Okay, next step is to find the table below. Okay, how to find the table below? Okay, in the upcoming slide we will be discussing about the table below, how to read the table below from a T table. Okay, next and final step is to draw conclusion. Once you have your test statistic, that means your calculated t value, and this is your tabulated t value. Accordingly, you have to decide whether if your test statistic or your calculated t value is greater than your tabulated value, then your null hypothesis is rejected. That means your test is significant. Accordingly, we have to draw conclusion. This all about testing procedure. What are those steps? First, we need to formulate our null and our alternative hypothesis, then level of significance, then your test statistics, then we have to find the table value, and finally we have to draw conclusion. Okay, so let's take an example here. Here I am considering one sample t test, and here is saying that based on field experiment, a new variety of green gum is expected to give an yield of 13 quintals per hectare. The variety was tested on 12 randomly selected farmer fields. The fields were recorded as the dash. Do the result confirm the expectation? So here we are dealing with one sample t test. First step, what was our first step? Our first step is to draw the null and alternative hypothesis. So what is our null hypothesis here? Whether the new variety of green gum, the yield of new variety of green gum is 13 quintal or not. This is our null hypothesis. Okay, next is alternative hypothesis. Alternative hypothesis is what we are trying to test. We are thinking that the yield of the new variety of green gum is not equal to 13. Okay, this is what we want to test. Next step is to find the level of significance. So if nothing is mentioned in the question, we'll fix our level of significance at 5%. Okay. Okay. Next step is to calculate test statistic. This is our formula of test statistics. X bar is your mean here, sample mean. Mu null is given in the question, 13 by S by root over n. Okay. Here it's saying degree of freedom is equal to n minus 1. N minus 1. See, n is your number of observation, but here we are subtracting 1 from number of observation. Why? Because here in null hypothesis we are considering only one parameter, that is mu. For that reason we are subtracting 1 from n. Okay, this is how we calculate degrees of freedom, that I already explained in my previous video of test of hypothesis. Okay, here now it's very easy to calculate x bar and s from this table. Okay, now I'm not explaining those things, the calculation part, I'm skipping that thing. Okay, from that table I have calculated x bar and s, and if you calculate all those things, we'll get the same thing. Here we have s is equal to 1.01. So accordingly this is our t test, that means x bar, this is our x bar, that is mean, minus mu null, that is 13, divided by s minus divided root n. N is equal to 12. Okay, so this is our calculated t value. Remember, calculated t value, test statistics, these are same. Okay, now next step, our next step is to find the table value. Okay, I will show you how to read a t table. Okay, but for the time being, just remember that here for degrees of freedom 11, why 11? And equal to 12 minus 1, which is equal to 11, at 5% level of significance is 2.20. So which one is greater? 2.20. That means our tabulated value is greater than calculated value, which is indicating null hypothesis is accepted. We don't have enough evidence to reject our null hypothesis. That means we may conclude that the result conforms to expectation. Okay. Okay. Next we'll discuss about the t table, how to read a t table. So let's talk little bit about the various component of a t table and how to read them depending on what you are using. Okay, so first thing first, before going to read the table, you should know what is your degrees of freedom, what is your level of significance, and most importantly, whether you have got a one tail test or two tail test. Okay, let's take the previous example. So this is basically a two tail test. I'm saying this is a two tail test because This is based on alternative hypothesis, which is showing mu is not equal to mu null, which is a non-directional or two-tailed alternative hypothesis. Okay, that means we have to refer the two-tailed row. Okay, now in the previous example, the degrees of freedom was equal to 11 and level of significance 5%. 5% level of significance. Okay, 5% level of significance here. Okay, and now see 11 and 5. This is the intersecting cell, which showing our table value is 2.201. Okay, see 2.20, which is your table value. This is how we read a table. I hope you that makes sense to you people. Okay, next is t-test for two sample. In the previous example, we were working with one sample. Now we have two different sample. Here we can see variety A and variety B. Remember, for those things, accordingly our test statistic will change. Okay, What is given here? Two varieties of potato plant yielded tubes are shown in the following table. Does the mean number of tubes of the variety A significantly differ from that of variety B? That means what he exactly wants to test is whether mean of variety A is equal to mean of variety B or not. So first thing first, we need to decide what is our hypothesis, null hypothesis. Null hypothesis, what will be null hypothesis here? Mean of first variety is equal to mean of second variety. Mean of first variety equal to mean of second variety. Next is our test statistics. So here the test statistic is quite different. X bar minus 1 y bar. X bar showing mean of A variety A and y bar showing mean of variety B. So here what we are doing, this is the deviation of mean of these two variety divided by S root over 1 by n1 plus 1 by n2. n1 n2 is nothing but the sample size. n1 is the sample size for variety A and n2 is the sample size for variety B. Okay, remember here our degree of freedom is equal to n1 plus n2 minus 2. Why 2? Because here mu1 and mu2 we are deriving these two from two different sample, not from one sample. Okay, so this is the table here, and from this table we can calculate easily the t value, x bar, y bar and s. Okay, so here this is the formula of s. Okay, this is the formula of s, and if you calculate the value of s, you got this value 0.3 kg. Okay, this is the t value using this previous formula. I've calculated t value here, which is equal to 3.77. Okay, now what I have to do is we have to find the table value, which is equal to 2.09. Now what was our degrees of freedom? n1 plus n2 minus 2. What is your n1? Let's calculate. n1 is equal to 11. n1 is equal to 11. How? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. n1 equal to 11, n2 equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N2 equal to 10. Okay. This is how we have calculated the degrees of freedom. 11 plus 10 minus 2, that is your 19. And 5% significant. This is the tabulated below. So here we can see the calculated value is greater than tabulated value, which means the null hypothesis is rejected. That means we can conclude the mean number of tubes in the variety A is significantly differ from variety V. Okay, this is how we draw conclusion. So remember, drawing conclusion is the main part of testing of hypothesis. Okay, next is our pair t-test. Pair t-test is nothing but here we are dealing with dependent sample test. Okay, what we are doing is here we are dealing with same population but two different sample of same population. Here we are collecting data from the same population but before and after applying a treatment. So let's take an example here. First is here saying that the average number of seeds set per pod in Lucerne were determined for top flower and bottom flower in 10 plants. See, here 10 plant is constant. The value observed were as follows. Test whether there is any significant difference between top and bottom flowers with respect to average number of seed set per plot. Okay, here what is our null hypothesis, which is equal to mu d equal to 0. Mu d is nothing but mu x minus mu y. So here we are assuming that mean of top flower, mean of bottom flower, difference between these two is equal to 0. This is our null hypothesis. Accordingly, this is our test statistic, that means mod d bar, where d is equal to xi minus yi divided by s by root n. Here this is the formula of s. S is nothing but s square is the variance of deviation, and d bar is the summation di by n. Okay, so here notice, I think you have noticed one thing, that in case of pair t-test and one sample t-test, two sample t-test, steps are same, but only thing is changing is your test statistic. That you have to keep in your mind. Rest things are same, the steps are same, the procedures is same for all, but here the basic difference between these things are test statistics. Next, using this table we have calculated d bar here, s square here, s, and according to t, which is equal to 1.65. And now we know how to read the t table, and accordingly our degrees of freedom equal to n minus 1, n is equal to 10 minus 1, that is your 9. Okay, 9 with 5% level of significance is 2.26. Now we have to compare these two, that is calculated t value and tabulated t value. Here we can see the calculated t value is 1.65 and tabulated t value is 2.26. That means calculated t value is less than tabulated t value, which means null hypothesis is accepted, or we can say we are unable to reject the null hypothesis. That means we can conclude that there is no significant difference between top and bottom flowers with respect to average number of seed set per plot. I hope that makes sense to you. So that's all for today. Thank you for listening. I hope you enjoyed this video, and if you like my effort, you can subscribe to my channel, like my video. Thank you. See you in the next lecture.